That's part 2 for chapter 4, section 4.2. This is the log functions. So let's review once more this properties of logarithms. Function is given as log of x with base a. Domain of log functions is set of all positive real numbers. Range is set of all real numbers. X-intercept is 1, 0. There is no y-intercept. Y-axis, that is x equals 0. That's the vertical asymptote, no horizontal asymptote. Log function is decreasing when you have this a, the base of log function is between 0 and 1. And if it's increasing if this a is greater than 1. The graph of f always contains these 3 points, 1, 0, that's your x-intercept, a, 1, and 1 over a, negative 1. When x is a, function value, that is y is 1. When x is 1 over a, then function value or the y coordinate is negative 1. The graph is smooth and continuous, and there are no corners or gaps in it. This is the graph of the natural log function. Y equals natural log of x. Natural log is the log with base e. This is how it looks like. The points 1, 0. This x-intercept will always be there, 1, 0. Then e, 1, and 1 over e minus 1. These 3 points will always be there on the graph. That's what it looks like. Now let's take some more examples to see the graph of log function and its inverse. Okay, now we have to find the domain of this function, negative natural log of x minus 2. Natural log means log with base e. We have to graph, and from the graph we have to find the range and vertical asymptote. Okay, fine. Now this is the natural log of x. That's the parent function. Now in this one, x minus 2, that means a horizontal shift 2 points to the right and a reflection over x-axis. So that's what it would look like. The final graph will look like this. See, initially the vertical asymptote was this, x equals 0. Because it's a vertical shift 2 points to the right, the vertical asymptote moved 2 points here. So x equal to, that's your vertical asymptote now. So now the domain, how will you find the domain now? Is the domain is 2 to positive infinity. So your domain is x such that x is greater than 2. That handwriting is really bad, but x is greater than 2. 2 to infinity, that's your domain. The range is all real numbers. Vertical asymptote we found out. Now next, let's see what is the next question. It says you have to find the inverse of f and use f inverse to find the range of f, and then graph of f inverse. Now inverse function of logs is the exponential function. So whatever the graph was that we drew, we have to reflect that same graph in this line y equal x. So we get this graph. The green one is the inverse functions graph. Inverse of this function will be e to negative x plus 2. These 3 points will be on that graph. These 3 points switch their domain and ranges. Those points come here on this green graph for inverse of f. The horizontal asymptote is y equals 2. Whatever the vertical asymptote was, x equal to, so the same number, y equal to, that becomes your horizontal asymptote now. The range is 2 to infinity and the domain is all real numbers. for inverse of the function. The common logarithm function is log with base 10, and if there is no base written there, that means log with base 10. That's the common log functions. This means 10 raised to y equals x, and this is this pink graph. That's what it looks like. Let's do some more example. It says find the domain of the log function with when fx equals 3 times log x minus 1. Graph the function, and from the graph determine the range and vertical asymptote of f. This is what it looks like, the parent function. Now you have to replace x with x minus 1. That means the horizontal shift 1 right, and then this 3 tells you the dilation, the vertical stretch in it. So it's vertically stretched by a factor of 3. So because it is a vertical stretch, you see that x coordinate does not change. This 1 times 3, that this is the point here. 2, 0 will still be 2, 0. The x-intercept is not going to change. This point is going to change, just the y coordinate. So the range is negative infinity to positive infinity. The domain is 1 to positive infinity. And vertical asymptote is x equal 1. So you have to substitute this x minus 1 is greater than 0. So x has to be greater than 1. That's how you find the range, the vertical asymptote. The inverse of f. Reflect this graph in y equal x line. Whatever the point is, switch their domain and range, switch their x and y. 3, 11, 3 becomes 3, 11. 2, 0 becomes 0, 2. So it's y-intercept instead of x-intercept. Whatever was the vertical asymptote, x equal 1. Now y equal 1 becomes the horizontal asymptote. Let's solve some logarithmic equations. Okay, so this is what's given. Example A is log with base 2 of 2x plus 1 equals 3. First thing, change that to exponential form. So 2 to 3 equal to x plus 1. Now 2 to 3 is 8. Now solve it for x, which is 7 over 2. You can check it, put that back in there and find it. Now this log with base x of 343 equals 3. So that means x raised to 3 equal 343. What number raised to 3 is 343? 7. And you can check that, plugging in there. When you have to use the logarithmic functions to solve the exponential equations, if this is given, 2 times e to 3x equals 6. So first thing, divide both sides by 2, isolate the exponential, e to 3x equals 3, change to logarithmic function. So natural log of 3 equals 3x. Now find out the solution. That's your exact solution. If you write that, you solve that natural log of 3 and solve it, this becomes the approximate solution. Right now, this is the exact solution. This is the approximate solution. Approximately equal to 0.366. Now let's again review the summary of summarize the properties of log functions. Domain is 0 to infinity, range is negative infinity to infinity, y equals log with base a of x means x equals a to y, x-intercept is 0, 1, y-intercept none, vertical asymptote is x equals 0, y-axis, that means y-axis, and it's increasing. So the graph looks like this. And when a is less than 1 but greater than 0, that's what the graph looks like. Now some more properties of logs, some rules of logs. When log of 1 equals 0, always remember that. Log of 1 equals 0. Log with base a of a equals 1. When this base and this number are same, then it equals 1. And this property, these m and a, they both are positive real numbers. A is not 1 and r is any real number. Now a raised to log of m base a equals m. See this, a raised to log a, they cancel each other. So this equals m. And also same thing as log with base a of a to r equals r. The exponent, this r, just comes here. Here they cancel each other and m comes here. We're gonna do some some examples on that. Some more rules of logs are this. Log of product is equal to the sum of the logs. If m times n, you're taking the log of this, any base is same base, log m plus log n. This is the product rule. Then the quotient rule. Log of quotient is the difference of logs. Log of m minus log of n. And when you have this log base a of m to r, this exponent comes in front of log. So r times log of m with base a. And if m and n are equal, then log of m equals log of n. If log of m of a equals log of n of a, that means if the logs are equal, then the numbers are equal too. And this is the change of base formula. If you have to change the base, so right now this is log with base a of m. If you want to change this a to base to some other base, let's say b, then it is log with base b of m over log with base b of a. We'll do some examples, more questions, more examples in the class. So please go through this video. See you.